Okay, so you might want to make a little note on this one, although it's going to be kind of hard because I've got a graph here, and we're going to try and sketch this graph together. So, but you can get the idea of it. Again, this note will be posted, so you don't have to copy it down. Understanding where it comes from is really what's important. So we're just going to reiterate what I did this morning about using the pencil test to draw. When we did it this morning, we had the experience of seeing what it looked like already, so that helped. We also had a bunch of slopes that Desmos gave us, which helps. Here we're going to do it all on our own without knowing what the picture looks like, and without Desmos to help us with any numbers, okay? But we have learned a lot this morning about what this shape might look like. So the first thing that I would look at is the original is this red function, and we're going to try and sketch the derivative of it in the graph below. What degree do you think this original function is?
4.
Mm-hmm. So that's a good guess. We know that it's 4 because it's got that extra bump. It opens up. So it's probably a quartic. It could be degree 6 or 8 or 10, but chances are it's degree 4, which means how big is the degree of the derivative going to be?
Three.
Thank you. Yeah, it's going to be 1 less than that. It's going to be degree 3. And even if this was a degree 6, then the derivative would be a degree 5, but the shapes would kind of look the same. But I am going to probably a good guess is degree 4, which means I already know that the shape of my derivative is going to be probably like a cubic. Okay, so now remember, cubics look a couple of ways. They can look like this, or they might look like that. Those are both cubics, right? So I've got an idea of what it's going to look like. The other thing that I might know is that the original graph has a positive leading coefficient because it opens up and up. And so if the original has a positive leading coefficient, I might predict that the derivative will also have a positive leading coefficient, which means I'm imagining something like this as opposed to something like that, okay, because of what the original graph looks like. Now, let's do the pencil test on this to see what it is, okay? Now, you'll notice that my derivative graph doesn't have any numbers, and I've done that on purpose. The x values in the derivative graph match the x values of my original. So obviously that's 0, this is 2, and this is 4, okay? The x values match. The y values match as well, but I've decided not to label them. And the reason is, and if you think back to when we were graphing polynomials last course, when we were graphing something like this, remember we didn't know how high it went or how low it went. So we made a guess about how high or low it went. And I said, we'll need to wait until calculus to actually know where that is. So we're going to start learning exactly how high and how low it is, but we're not there yet, okay? But so right now, our sketches are still going to be sketches, but we are getting a little bit more information to make them a little bit more accurate, okay? But still, I'm not going to label the y-axis because of that, because I don't want to say it's going to actually go up to 2 and find out later that it actually went up to 3 and feel like my graph is wrong. Okay, so let's go off and do the pencil test. So I'm doing the pencil test right here, but I'm going to draw those awful looking tangents all over my original and get an idea of where it goes. So first, Jenna, tell me about the first tangent on this red graph.
It's negative and steep.
Negative and steep, which means the number is going to be a big negative. Okay, excellent. So it's negative and steep. So my number is going to be a big negative. That means it's going to start somewhere down here. Okay. Because I don't know how steep it is, I could estimate, geez, that's pretty steep. Maybe it's like a 10, or we've seen sometimes it's like a 47. Sometimes it could be even like a 5, still steep, but I don't know exactly how steep it is yet. I could go off and actually try and calculate the slope of that line, but then I'd be doing what Desmos does really, really quickly. But you can see it's already inaccurate. Like, I don't know, is that like a slope of 6? I don't know. So I'm not going to stress about it. I'm going to estimate how steep it is. But I definitely know it is a big negative number. And then as I draw my pencil test along here, these slopes become smaller and smaller. And so the graph is going to become smaller and smaller and smaller. So my points start here, but start getting smaller and smaller and smaller and smaller. Okay, so I know that. Actually, before I go any further, I'm going to add a couple other points that will help with my picture, even though I'm having a good conversation there. And those couple of points are the local maxes and local mins, because even though I don't know how steep some of these other curves are, I do know how steep those are. So for example, this spot right here, I know the tangent is 0. And so I know the derivative for that guy is going to be, I'll do it in blue again, is going to be 0. So I know my derivative is going to pass through that spot for sure. There's 2 other spots where I know the derivative is going to be 0. Right here, the tangent is going to be up at the top, and right here. So for this guy, I can see that it looks like it is at its max at 2. And so I know the derivative is going to go through 0 at 2. And similarly here, there's another spot, it's min, where the derivative is 0. And so the slope is 0, so the derivative is 0. So I got those spots. And I should probably start with those because they're easy to find and they'll help me aim the rest of my graph. All right, so I got those guys. I know it starts down here, and I imagine it's going to go up like this. Okay, I don't know if it's not curved like that. Okay, so it starts, I know it's big negative down here. So I'm just doing these little trace dots along here, and I know that eventually they get smaller and smaller and smaller and smaller. These slopes get smaller and smaller and smaller and smaller until it gets to 0. Then you can see on the pencil test, it starts to get bigger and positive. Now they're not very big at first, but then they do get steeper and steeper. So my derivative is going to start getting positive numbers. They're not very big at first, but they are positive. So they're starting to go up. Now, remember I said that this graph is going like this. And so at some point on this red curve, it's not so steep, and then it gets really steep, and then it becomes less steep. So somewhere in here, usually in the middle, but not always in the middle, somewhere in there, it is at its steepest. And then it goes back and becomes less steep. And that's the spot in my derivative. So if that happens kind of at 1, that's the spot where I'm going to get to the highest. And then my tangents are still positive, but starting to get smaller. So they're getting smaller. My pencil comes closer to 0. And so I got my steepest spot, and it's coming down, and it's going back to 0. Now, how high that bump is, you could, if you wanted, actually go off, and I'll erase some of these, and draw a secant, something like that, and actually measure the slope. So you could go off and say, okay, I'm going up 2 and over less than 2, so I'm going to guess that it's about a slope of 3. And if you wanted to make that guess, then you might change your graph and say, you know what, this derivative only goes up to like 1.7. I'm going to actually have it go up to 3. So you could change your picture just a little bit and say, you know what, I think it goes higher than that and comes about that. Now, the problem with what I just did was it's all an estimate. I'm only drawing a secant. That secant's not great. And I'm roughly doing the numbers there, okay? Somewhere between 2 and 3. You could argue that it's not quite that steep, that maybe it should go only up to like 2.5. but I'm not going to stress too much about exactly where it goes up, just that it goes up a reasonable guess the amount, okay? I don't want you to come up and say that it goes up way like this, because that graph is definitely not up at like a steepness of 10, and it definitely isn't a little bump, because that steepness here is at least more than 1, so I don't want to see a little bump. But whether we draw it at 2 or 3 or 4 or 1.5, I'm not going to lose too much sleep about that. All right, so I've been doing my tangents, smaller and smaller gets to 0, now they're positive. There's the steepest one, then it gets back, tangents, 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 and then it gets back to 0. And now I have this sort of repeating happening, but all in the negative direction. Negative, small, until a steepest spot. And again, I feel the steepest spot is right there. And it's going to go down. And the steepest spot is about here. And then what did the slopes do? They get smaller and smaller. They're all negative now, though. It's getting smaller and smaller, closer back to 0. So the dots come back to back to here. And then it hits 0, and now the slopes become positive again. And they're getting steeper, steeper, steeper. And then the graph goes off. And I'm doing all those dots just to sort of guide my drawing and saying, okay, I feel pretty good about this. So now I'm actually going to draw what I think the derivative looks like and sort of go like this. And say that this is the derivative f prime. Okay? So although I said that I didn't care how high it went as long as it was a reasonable estimate, what I do notice is the original graph kind of has some symmetry, meaning this little section up here is kind of the same as this little section there, which means when I do the derivative, this part and this part, even though one's positive and one negative, should be relatively the same, okay? Because the original graph is kind of the same in those two spots. If you had the derivative going really steep here and not as steep there, the original graph would be something where it would go really steep and then not so steep later. It would look something like that, right? Where you see these are steep and these are not steep. And that's what this graph would be doing, really steep and not steep. And that's not what's going on in this scenario. In this scenario, the bumps are about the same. Derivative should be about the same as well. So I will be critical about that. You see I went up to 2.5, so I should go down to 2.5 because it's about the same. All right, so there's all the work that I did in drawing my derivative, and now I'm going to see how I did. Not bad, pretty close. There we go. Oh, I thought I had this traced over. I could trace one over the other. Oh, it's there. There it is. Wow, you can hardly even see the red graph. That's amazing. Is it there? Oh. That's why you couldn't see it, because it wasn't there. All right, but it looks pretty close. I think I did a pretty good job at drawing that. I think maybe this would be a little bit higher. Look at my the height. The height, it turns out the slope was only about 1.7, and I went up to like 2.2. That's okay, I'm going to live with that. So it turns out it's not quite that steep. And so down more like that, and that's okay. All right, I was making an estimate, so I've done a pretty good job at drawing this. All right, so what we're going to try and do now is draw these together. Now, we're going to try and draw them on Desmos, okay? So these 3 examples are all on Desmos, and I will now translate over there. I'll release the activity so you can come on and find these examples on Desmos.
So let me know. I'm noticing you're watching the video and then there's no sound on the video, and then you'll be on slide 2. I'll wait till everyone gets over to slide 2 and has a chance to watch the little video. Okay. Looks like almost everybody is over on to slide 2 now. And I'm going to walk you through that. Okay, so I'm going to pause you. So I apologize for that. If you could come back to the Google Meet, and I will just demonstrate, and then you're going to try it on your own, and then I will send you off. So come back to the Google Meet. So here is the exact same question that we just sketched, but I'm going to show you how we're going to do it in Classroom. You watched the little video, so you should have an idea of what we're going to do it. But what we're going to use is this sketch tool. The dots that are the default are okay. I'm just going to make my dots a little bit bigger just so you can see it. You could do that too for your idea. But we're going to sketch using the dots just like I did on the smartboard, but using it here. So the first thing I recommended was graphing the maxes and mins, because you know the slopes are 0. So I'm going to put a dot here. It's going to be at 0. I know this max here is going to have a slope of 0, so the derivative will be there. And this min is also going to have a slope of 0, so it's going to be a dot there. We already talked about how the fact is it starts negative and steep. So I'm going to start down here. Just hide that. And it gets less steep, less and less steep. So it's going to come up. So I'll make another dot here, a couple of dots here, and it's coming up to this point. Then it starts going positive. And the spot where it's steepest is in the middle. And we kind of learned before that it's about like 1.8. So I'm going to make my highest spot maybe about there. Although I feel like maybe this one is a little bit steeper. I don't know. Let's guess there. Yeah, I think it should be steeper, but let's guess. Okay, and then it starts coming back down to 0. So we have it here, and then we're going to have this part again. The steepest spot is right there, so I'm going to have it right about down this. It goes negative, then it gets to its steepest spot, and then it comes back, and we get it through 0, and then the last ones are all positive and getting bigger. So I'm going to guess it goes something like this. Okay. And you do not need to then actually draw the final part, because that's the hardest part with the mouse. We're going to use these dots as the reference, okay? And once you've done this, what you'll do is move to the next slide, and then you will see the derivative and your answer. Yeah, I expected it to be a bit higher. So maybe I should have double checked that. So I did think it would be up to 3. Okay, so I should have maybe had that a bit higher, but I have a pretty good idea. Everything else looks pretty good. So you're going to do this sketch and then go to the next slide and see how it did. Don't go to the next slide until you actually have tried it on your own. Otherwise, you'll have an idea of what it looks like, and then you'll be cheating the whole way. You're cheating yourself the whole way. Okay, so that's what our plan is. So I'm going to then open it up one more slide and just see how you guys did. Again, this is the same one that we just did together on the whiteboard, so you should have some influence. What it looks like. Yes. 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 I'm just looking through everyone's. Really good. Really good. Yep. 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 Nice. Good. So most everyone has done that, and then they're checking their answer on the next one. Okay. So just looking. So if you're done the sketch, could you just go over to slide 3 so that I know that you're done it? I can see here as you move around. Good, almost everyone is over there now, which is great. Okay, good. Okay, so almost everyone has done their sketch. So what we're gonna do is 3 more. And this is the ones that you saw on the smartboard, but I'm just gonna release them sort of slowly. We're gonna do one at a time. So I'm gonna release the first one and just check everyone's graph, and then I'll show you what the answer is in a second. So if you go over to slide 5, you should be able to see the one you're gonna try next. So I'm just going to look at people's graphs. So I'm seeing lots of good sketches. Oh, someone actually tried to draw it, which is impressive.
This is glitching for me, so I can't really like write it properly.
I'm sorry, say that again.
Desmos is glitching for me, so it's not really letting me like draw where I want to.
Okay, all right. That's okay. You can try your best, and if you want to draw it by hand and then you can check the answer out after, that's fine too.
Okay.
Thanks for letting me know. All right. Okay, so I'm seeing some pretty good graphs. I'm going to release the next slide so you can check your answer compared to that graph. So you can see how you did there. Okay. So I see some pretty good graphs here, which is excellent. I also see people sort of adjusting their answers based on their learning, which is good. Okay, so don't be afraid to do that because you're learning how these look all along. Good. Good. Okay. All right. So I'm going to release 2 more, and this is something new. So I think you're actually going to, this is A, like I've called it sketch A. I'm going to try and skip ahead to F and see if this works. It looks like it's working. So now I want you to try F. And then I'm going to coach you on these 2 and then release the other ones. So as you're working on that one, I'll go back and look at your graphs for the first one. If I notice anything from the first one that I might need you to fix, I will let you know. Okay, so in A, I'm really impressed with everyone's graphs in A. So we'll see how you're doing in F. Okay. Okay, I'm going to release the answer to F. Okay, so forgive me if you're in the middle of doing your sketch. I'm just going to pause you for a second and then just talk about what I'm seeing. Okay, so let's just pick someone here. Okay, so what I'm noticing, and I would say almost all the graphs that I looked at, everyone noticed one big difference, and that is that this part of the graph here is steeper than this part of the graph. And as a result, the derivative is going to go higher here than it does here. Now, your estimates are all a little bit different. Some people had it growing up to about there and then only down to there. Other people sort of had it going up to about here and then coming down, right? Like these are all good, and maybe this one's a little bit lower, but these are all really good estimates. I'm okay with whether you get it. I'm okay if you don't get this part perfect or this part perfect. But what I would challenge you on is if you don't have this part of the graph higher than this part of the graph, because this is steeper in the positive direction, so that part's going to be higher, and this one is not as steep in the negative, so it's going to be lower. And so let's see how Florence Nightingale did here. Oh, really good. Okay, so I would give this full marks because they got the zeros right. They estimated it would go up to here. Turns out it goes up a little bit higher. Their low part, though, is about exactly bang on, and then the rest of the graph is going great. Their zeros are all good, so I would say that that's getting full marks. Again, this one looks like a first attempt and then a second attempt afterwards, but the zeros are all good, so full marks. Again, this one, full marks here too, because this one's higher than that one. So I can see that people are doing this. Oh, wow, maybe that person went back and tidied it up, but definitely full marks there. Okay, where I might not give full marks, I don't think I'll have too many examples of not good ones. Yeah, these are all great. But what I might, let's go here, go back. What I might not give full marks is someone who just does, you know, like doesn't really highlight, should make these bigger, doesn't really highlight that one is taller than the other. You know, something like that is not good enough. Okay, you can see that it almost looks like it's going up the same amount for both, and this one is clearly higher. Okay, so I'm okay if you only go up this high, and we're supposed to go up there, just that this part is higher than that part. The other spot where I would challenge is if you get your zeros off. So for example, if you have it crossing here, it definitely doesn't cross there. Okay, the low point is right here, so it should cross right there. That one would be off. Same with this one. You know, it doesn't cross there. This one is about at zero, and it crosses right there. But this part here would be wrong. So I would mark that as wrong. Okay. All right. So what I'm going to do now is give you about 10 minutes to play around with the other ones that I've hidden here, and unhide these. So go back and try B, C, D, and E. So you're going to go back to slide 7 and try some more of those. But I feel pretty confident about how things are going. I'm going to give you about 10 minutes to do that, and then we're going to finish the day with a game. So go back to slide, oh, I got to unpause it. Sorry. So go back to slide 7, and I love watching all of you racing over to slide 7 and try those ones. Okay. So I'll give you about 10 minutes, and I'm going to go try and grab my lunch. So I'll see you in 10 minutes. Stay in the Google Meet though, please.